Okay, so last time we were talking about which slide are we on over here? I want to find the where we are over here. Usually it selects it. There we go. Okay, so we were talking about primitive type variables, and we mentioned, the first four. These are coming from our, let's just call it from our perspective, or the oldest programming language that we care about. Okay, that's going to be the C programming language, and we're not going to say anything more about that right now. Well, we will next week sometime. But all of our languages today pretty much came from C at some level. Okay, so the four primitive types that exist in C are, the four integer primitive types that exist in C are byte, short, int, and long. We talked about them last time, and we said, okay, these guys, they can all hold signed whole numbers. And I asked the question, well, why do we need so many different ways of holding the same thing? All right, and then we had that, the oh wow moment of talking about how expensive memory used to be and how cheap memory is today. And I mentioned that I got a 8 megabyte, and we're going to talk about what that actually means, put that in some context today. Stick, which is 512 times smaller than a 4 gigabyte stick of memory, and we said a 4 gigabyte stick is like $30. That's at retail. That's if you pay top dollar. If you go off online somewhere, you can probably find it for $11 from some cheesemaker in Guatemala or something. But going to Best Buy, it's $30. Okay, that 8 megabyte stick cost me $1,000 back then. You want to take it to even another level. That same computer that I mentioned from 1996 came with a 420 megabyte hard drive. That was how big the hard drive was. Today you get a computer and it comes with like a 1 terabyte hard drive, right? Or if you get one of the newer machines, it's actually usually smaller than 1 terabyte, but it's the newer technology. It's the solid state drives, and they're a lot faster. At some point, we'll get off on a tangent about that, but you want a 256 gigabyte solid state over a 1 terabyte mechanical drive every day of the week, okay? But punchline is, if you go over to Best Buy and buy a 1 terabyte hard drive today, how much does that cost? Less than 100, right? $70, $60, yeah, whatever. You probably can get the Western Digital Green, whatever their budget pleaser one is. That we put this together with copper scraps, but you can get it cheap, right? That I wanted to get up to a gigabyte of memory, not a terabyte, a gigabyte of memory back then. So I bought a 540. This was them melding together. Today you just replace your hard drive, or you just have 2 hard drives, right? Back then I actually had a master slave thing set up, and but I've got a 580 ish megabyte hard drive, and that was another $1,000. Okay, so that just gives you an idea how expensive memory was, and again, that's after the price of memory had started coming down. You roll back the clock. I mentioned last time that famous guy, Bill Gates, Microsoft dude, once had a famous quote, "You'll never need more than 32K of memory." We'll talk about what K means here in a few minutes, because K can kind of have a double meaning. But we need more than that, seems like, right? Computers have taken some interesting twists and turns. Okay, so let's look at this chart thing here, and then we're going to talk about some conversion stuff. All right, so we have 2 different columns here. We have a column over here that's based on the concept of a bit. Okay, a bit is a single 0 or a single 1. That's a bit. So we talked about binary before. A bit is a single 0 or a single 1. Over here, we have a thing that's a collection of bits known as a byte. So these scale off of something called a byte, which is a collection of 8 bits. All right, so in computer science, we would have kind of 2 primitive things that we should always remember. A bit versus a byte. A bit is a single 0 or 1. A byte is 8 of those. Make sense? All right, bit versus byte. So within that, we have the idea of a kilobit, a megabit, a gigabit, A terabit, small b, means bit. On the other side, we have the idea of a kilobyte, megabyte, gigabyte, terabyte, and then we can keep going from there. But that's where we're at right now. Okay, big B means byte. It's a multiplier of 8. All right. So now, how many of you have internet at home? What's the speed of your internet? Anybody know what speed internet they have? If you're a CS or an IT major, every one of you should know this kind of stuff. So start learning it starting now. Who says they know the speed of it? Go ahead.
It's like 50 down, 10 up.
50 what?
50 download.
It's not download, it's not a measurement of speed. 50 what download? What do the commercials say? Commercials say meg. 50 meg down. Right? We got something? It is megabits. Okay? But when they talk about it in the commercials, they say meg. Sometimes you'll even be at like the store or something talking to somebody, and they'll actually say megabyte. Because you're, idiot consumers, you don't know the difference. Right? In fact, probably most of you before this morning didn't know the difference. Meg's a meg, right? Okay? So a lot of times you'll go and you'll get, so anymore, it seems like around this area, Spectrum, for instance, their budget pleaser internet is 200 megabits per second. They just bumped it from 100 to 200 for the same, whatever their cheapest price is. So let's say this is 200 megabits per second. We see the little small b there, okay? Although the commercial would say meg, 200 megs. And then they say it like really cool and stuff like that. There's usually like a little flame logo somewhere, and then they like a cat caught on fire. They just have all this stuff. Well, the cat lives. It's just running away, and it's on fire. It's going to put it out and all that stuff. All right, so 200 megabits per second. What does this translate to us in terms of what can we actually do with this? Now, he mentioned that we actually have he had a certain speed down and a different speed up. What's the difference between down and up? In as far as internet connection speeds go, I'm not asking you like, yeah, you were the down up guy, right?
When you're downloading something versus when you're uploading something.
Okay, when are you uploading something?
Like if you're uploading a YouTube video or something.
Okay, yeah, good example. That's actually a kind of the perfect example of it when it would really make a difference, right? Historically, when you might be uploading something like sending an email and like attaching a Word document, does it really matter how fast your upload is? I mean, a Word document's pretty small. It's like, 18K. K what, right? It's usually kilobytes. But in any case, your upload is when you're sending something up somewhere, and that's got to be slower. Okay, because now it doesn't have to be slower, but usually when your internet provider is selling you bandwidth, they're saying, look, a majority of what you're going to be using your internet connection for is for digesting data. You're downloading, you're streaming Netflix, you're loading web pages with a bunch of pictures on them, stuff like that. You're downloading your email, whatever. Okay, every now and then you are uploading something, even if it's a YouTube video or something like that. But I mean, what do? You started uploading and you leave it, go get dinner or something like that, right? No big deal. Why do you think they don't want your upload to be as fast as your download? It's not that because they can't deliver it to you. I mean, it would take them more bandwidth, or they would steal some of your upload or some of your download to give you more upload. But what do you think their rationale is for not giving you as much? Because typically, upload is far slower, right? Like this might be 200 megabit down by 7 megabit up or something like that, ballparky. Why do you think it's so much slower? Go ahead.
Well, maybe just to check to see if there are any kind of like errors with uploading to make sure it processes right.
Yeah, it's not. Yeah, I mean, reasonable enough thought. Not the reason.
Okay.
Go ahead.
They could probably assume that we're not going to be uploading as much as we're going to be downloading.
That's a fair enough assumption. We're not going to be uploading as often, but a lot of times when we do upload stuff, we're uploading bigger things. Like with the YouTube video thing and stuff like that. So, maybe the nice guys at the cable company, or DSL, if you're on the AT&T side, might be thinking that. Go ahead.
A little more from a business perspective, it's cheaper.
Could be. No, we're still missing the main one. Go ahead.
Bunch to buy more, so if it's slower, then you have to.
Yeah, but in order to get what's called a synchronous connection, same speed up and down, you got to go over to their business side. And it's a lot more expensive for business internet. You know, they'll throw that little caveat. What? That's something wrong with this one, right? Yeah. There's something going on here. They'll throw that little caveat on there that, well, we guarantee 99.997% uptime or something like that. But the reality is, if our consumer internet goes down for even 2 seconds, we're screaming, right? Yeah, so that's doesn't mean anything. Any other last guesses? It's actually, I gave a hint to this earlier today when we first started class. So they don't want you to run a server. Okay? They don't want people running servers out of their own homes. All right? And they do this. Some of these concepts are going to be more of a networking class concept, so I'm not going to get into those. That's why they give you fake IP addresses inside your house, and then you have to use a network address translation and crap like that. And there's ways around it, but the punchline is they try to make it as inconvenient as possible for you to run a server out of your house. And they start off by making it that your upload is relatively slow. So even if you did figure out a way to run a server, it wouldn't be a real great server, because your upload is whoever is downloading from you's download. Downloading from you's, we'll call it Philadelphia speak. We're good. All right, so yeah, so they purposely slow down your upload, so you don't run servers out of your house, streaming movies, things like that. You can still do it, but you're probably going to have just you and 3 of your best friends who are able to access it at one time before it's no longer worth, getting that slideshow video streaming to their house. So what has the internet done as to combat this? BitTorrent. Download a little bit from a zillion people. That's how BitTorrent works. If most of us, not that any of you have ever used BitTorrent to download anything questionable, right? There's perfectly legitimate reasons for things like BitTorrent. Like most of our software patches for applications now, video games, stuff like that, comes through a BitTorrent type technology. So plenty of legitimate uses. But typically when you hear somebody saying that they're torrenting stuff, what aren't they paying for to see in the movie theater, right? That's what immediately goes through your mind, right? But the idea is that, and most of us, we're jerks, right? As soon as none of you in here, I'm sure, have ever used BitTorrent for those kind of purposes. But if you were to use it for that kind of purpose, I'm guessing as soon as your download is done, you're going to turn it off so you're not uploading to anybody else, because screw them, right? Why are you going to feed the network if you already have what you wanted? Yeah, that's what most people do. Okay, but the idea is that everybody who has the file already continues to provide that file, bits of that file, to the network, so that other people who are downloading can download a little bit from you, and a little bit from you, and a little bit from you, so nobody's upload is fully maximized. Yet everybody can get a higher download from 20 different people's uploads. Does that kind of make sense? So BitTorrent's kind of to combat that, we're going to call it ethically from a acceptable use rationale. But, you take like a software patch from Microsoft or something like that. Even Microsoft, who has maximum upload speed, they're still going to have a limitation. If they have, 50 million people hitting their server at once, there's going to be a limitation. So that's why a lot of times they release updates in, kind of geographical batches or something like that, so then everybody doesn't get it at the same time. But what they do initially is they release it to a certain percentage that they can handle the bandwidth, and then the software updates and everybody else's starts pulling that data from all those different sources, not just Microsoft. So they kind of distribute the wealth, that kind of stuff. Okay, so now let's think about back to maybe what is more in our ballpark for this class. When we have a 200 megabit per second internet speed, let's think about what this actually means for us. Okay? Now, you can get 200 megabits per second, or you can get, how many of you have seen the 1 gigabit per second? Gig internet. All right? So gig internet is actually 1,024 megabits per second. Okay, that's what that guy is. And we'll talk about conversions here in a few minutes. All right. So if we're just sticking with the megabit per second measurements, 1,024 better than 200? Yeah, but do you need it?
Probably not.
Of course. Faster's better. Right? What do you use your internet for in your house? Well, you use a lot of web browsing, a lot of email checking, probably Netflixing.
Yeah.
Right? We're just turning all these things in. So, video streaming type stuff. Now, if you're in so how many of you have a 4K TV? All right, they've come down in price so much, tons, so you don't have to look at them and say, you spent 10 grand on a TV. You can get a 4K TV pretty cheap now. So how many of you have 4K Netflix? You're not worth paying the premium for the 4K stream. Okay, so if your 4K Netflix says the minimum internet speed you have to be able to handle 4K Netflix is 65 megabits per second. Because the idea, we can get into we talk about this in a different class, but, when Netflix secret sauce is their compression algorithms. When they're sending you that many bits for a movie and you're downloading it and watching it in real time, it is heavily, heavily, heavily compressed. And then you're decompressing it at your computer. So you're using your computer or your smart TV or whatever it is to decompress that video stream. Because, if you take the resolution of 4K, and then you multiply that out to get you a total number of pixels for a single picture, and then you multiply that by, let's call it, let's keep it an average, let's say 30 pictures per second. That's for a human being to think you're watching motion video, and then multiply that by an hour. You're talking about a really huge number in terms of the amount of data you had to download in that hour to watch that show at 4K. That's not the amount of data that's actually going across, because Netflix is compressing the heck out of that data stream so that it's relying on your computing power on the other end to decompress it. Okay, but the punchline is even if you're going to do 4K Netflix, which we'll call that the highest quality streaming stuff you can get right now. A couple of the other, Amazon Prime has some. I think what do they call super high def or something like that on there. So it's not just HD; it's the next Ultra HD or whatever the name they have for it. Let's call that 65 megabits per second. We'll let you pull that off. Now, if you have a little wiggle room, like 200 megabits per second, you're going to be a little bit better off, right? Okay, but generally speaking, I think we talked about that example the other day with assembly. We were talking about who had a computer with a crazy expensive video card in it, which versus somebody who had a computer with a borderline video card in it. Borderline's fine 95% of the time, but when you get into that area with tons of explosions, your game turns into a slideshow, and the guy with $1,000 graphics card, he's still going along. His frame rate dropped way down, but it was still way faster than he needed to for it to still seem like a smooth game. Right? Okay. I like when people walk by the windows, they're admiring my backpack. I can just tell. You can sometimes pointing to their shoulders. You see that guy? I like being the weird one. It's good. All right. So we're going to say 200 megabits is your budget pleaser internet today. If you live out in the boonies or something, maybe it's 50 or 60 or something like that, or worse if you're on DSL. But this is cable internet. But in any case, we would say as a human, 1024 way better. We should pay for that if we can afford it, right? Now, the reality is that you only really need that if you're in a household with lots of people who are digesting data all at the same time. You have 3 or 4 roommates who all have their own Netflix accounts, or you guys are sharing a Netflix account, whatever it is, but you're all watching Netflix at the same time, or you have 2 or 3 different Netflix streams going on at once and that kind of stuff. Because now that's going to start adding up. That's 65 plus 65 plus 65 and so on and so forth. All right, so when we start thinking about our much, 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 much higher download speeds, what we're really talking about is, by today's standards, servicing more simultaneous users. Okay? Now, that's also going to then support whatever the next technology is going to be. So after 4K, they're talking about 8K, and that's going to be even higher data rates, and now you're going to use a higher percentage of your internet and that kind of stuff. So the reality is, if money's just growing on trees, get the fastest internet they offer. If you want to save money for something else, buy the fastest internet that you need to do the stuff that you do. And then if at some point in time some new technology comes out that you really want to take advantage of, get the bump up your internet to the next level or something like that. Now, mistake that a lot of young folks make is, I asked the question a couple classes ago, how many of you are gamers? We got a lot of hands up, right? Is 1024 megabits going to be better for gaming than 200 megabits? No. What is gaming? I mean, when you have a video game, you have this real-time stuff going on, where you're seeing everybody else move on the screen. It's a lot of information, but it's relatively small data. You're just getting little packets of text that are telling you where this person is and where this person is and where that person is on the screen. So you're not even coming close to using your 5 megabits or 8 megabits of download speed for those data packets. Okay, it's not that much data to do it. What do you care about as a gamer? Ping, latency, right? So the time it takes for your computer to hit the server and come back. How often are you getting those updates? Does that make sense? The updates themselves aren't that big. You don't need bandwidth to get the updates. You just need to have the kind of the reflexes, if you will, to get the updates often, so that you don't all of a sudden have, I'm not very good at first-person shooters because things are happening too quickly on the screen for me. I'm more of a World of Warcraft kind of guy, okay? But, punchline would be like if you're a first-person shooter and you're lots of action, things are going on, and your target is over here, and all of a sudden your target's over there, you need better internet. Is what it is, because you didn't get updates quick enough. You didn't see all those little spots in the middle as he was running across the map. Does that make sense? Okay, so punchline for this lesson here is make sure you understand what does it mean to have good internet. Good internet does not mean fast internet in terms of download speed. It doesn't necessarily mean fast internet in terms of upload speed. Now, if you only watch Netflix, if that's your main use for your internet, and then email or something like that, does latency really matter? No. So fine, it takes an extra 3 or 4 seconds for your video to start playing initially, but then it's buffered and you just move on with life. Who cares? Doesn't even matter if you have 3,000 millisecond latency, which is a 3-second delay. Extra 3 seconds before it starts buffering initially, and you move on with life. You'll never know the difference. Okay, so those of you who really do live out, anybody really here live really out in the boonies? Have satellite internet?
Yeah, we had HughesNet.
Okay, yeah, not gaming friendly, right?
No.
But you could have watched Netflix on that.
600 ping.
Yeah, but you could have, well, actually, that's pretty good for HughesNet. 600 ping, that's only 0.6 seconds.
I guess.
Not first-person shooter quality, but I mean, sometimes things get a lot worse even on good internet with some sort of server problems. But punchline is you can still watch Netflix. No problem. Just took an extra 0.6 seconds to get the ball rolling initially, right? But humans are greedy. 0.6 seconds is a problem. Yeah, we'll complain about that. We'll complain about everything, right? He's like, look, I was downloading this file, and the file was, used to come down at, we see that actually this is on campus all the time, right? Because sometimes you have like crazy speeds on campus, and then sometimes you have speeds on campus where it seems like, that they're just kind of like messing with you. So sometimes you'll download at like 3 in the morning, and you'll be able to pull down a file at like, 14 or 15 megabytes per second. And then the next night you'll be pulling down, a similar size file, and it'll be coming in at like, 107 bits per second. It's a very, very different experience. But let's talk about what this means. So let's operate. What kind of? Let's operate off of a movie download. Okay, so let's say that we have a movie we're going to download that is. Let me just jump it up here. And this is a legal movie. This is some sort of documentary about the Book of Romans. Concordia style, right? All right, so we're going to say, we're going to have a 1,000, we'll keep it just to reinforce this this idea of 1,024 multipliers. We're going to have a 1,024 megabyte, or this is a 1 gigabyte video that we're going to be downloading. Okay? And we want to know how long that will take on these different internet connections, where our internet connections are measured in megabits per second. That is to say, we can't just divide this number by 200. Okay? So we want to know how many total megabits is 1,024 megabytes. You can actually just multiply it by 8. That was simple. But I'm going to actually run the columns to make this happen. All right. So 1,024 megabytes is actually equal to actually, let's just do instead of being crazy big numbers, we'll just do 1,024 times 1,024 kilobytes, which is actually 1,024 times 1,024 times 1,024 bytes, which is actually 1,000. Let me just copy from here. Which is actually 1,024 times 1,024 times 1,024 times 8 bits. All right, so this is going to give us a number in bits, which is that number. Okay, so I'll just put it in parentheses out here. But now we care about how many megabits that is. So we're going to take that number and we're going to divide it by 1,024. That's going to get us to kilobits. That number divided by 1,024 divided by 1,024 will get us to megabits. So let's just do that out here. So there's that number, 1,024, 1,024. 8192. So this is 8,192 megabits. Make sense? So then we take that and we download it by divide it by 200. 40.96 seconds, since we can do 200 megabits per second. So if you are able to absolutely maximize your internet connection, which isn't always possible, just because you have 200 megabits doesn't mean that the source you're downloading from has an upload of 200 megabits, right? It just means you're capable of downloading at 200 megabits if a source will give it to you at that. All right? So theoretically, you could download that file in 41 seconds. Not horrible, right? Now, you do the same math on 1,024. And I'll show you the jump trick. So we need to go from 1,020 while we're doing, this was 1,024 megabytes. We want to get that into megabits. If you do 1,024 times 8, there's your 8192. We just jumped columns because it's a multiplier by 8. We went from bits to bytes. Well, we went from bytes to bits. So we multiplied by 8. Okay, so that gets us to 8192 megabytes. If we want to get up to giga, well, actually, this is 8192 megabits. Sorry. So we want to divide that by 1,024. Possibly 8 seconds. Theoretically. All right. It's realm of possible. Now, there's all sorts of other things inside your computer we talk about, like in the 325 class, that, where are your holdups? Well, if you have an old mechanical hard drive, chances are you're not going to be able to digest that data at that speed. Solid state drives probably could. So, just because you can receive it at that speed doesn't mean you're actually going to be able to store it at that speed, and there's going to be some sort of slowdowns and things like that. But the more often you can have your slowdowns be inside your local machine, the better off you are, because there's usually hardware you can use to replace that. But if things that are outside of your machine are kind of outside of your control. Make sense? All right. So does this kind of make sense on the whole converting thing? So like on a quiz or something like that, if I were to give you something like this that says, okay, let's do 21,414 bits is how many megabytes? Go ahead and take about 2 minutes and try to solve that. So we're going from bits to megabytes. You got to jump that column and then do your 1024s in the right order. Very sad about this soda not being defrosted. Whoa! That was a mistake. I saved it mostly. It's much more defrosted now.
Yeah. I think that's the case.
Yeah, it was good.
Did you actually try to smash it to
No, because that would be too smart.
I'm just wondering how much that copper issue can build up.
All right, so let's take a look at this. So the first thing we need to do is we need to get it from bits over to bytes. Now, one thing I'll mention to you here is, first of all, I like to do all sorts of conversion questions like this. More commonly throughout your 4 years, we'll be converting between bases of numbers, which we'll start doing here actually right after this. But these are my fallback conversions from sizes. These are all things you should be comfortable with as technology majors. All right. So if you don't already know, like I mentioned before, if you don't know what speed internet you have at home, figure it out. That way you kind of have an idea of what kind of technology you're dealing with. That's what sets you apart from the normal consumers that walk into Best Buy or something like that. Because one thing I like doing sometimes is going into Best Buy and just listening to some of the crap that the salespeople tell them. Now, when you go to a Best Buy, usually let's say there's like 5 salespeople in the computer department. Usually one of them is really solid. They actually know what they're doing and stuff like that. But the other 4 are just making stuff up. Okay? And the thing is, if you're just your average consumer, you don't know. You're just being lied to and you have no idea, right? So don't be that person. Okay? So if you're going to go work at Best Buy, be the smart one. And if you're going to go shop at Best Buy, be at least as smart as the smart one and be way smarter than the other ones that are just giving you crap. All right, so 21,414 bits. The first thing we're going to do is take that over to bytes. What do I need to do to get that to bytes? Okay, divide that by 8, okay, because there is 8 bits in 1 byte. So 21,414 divided by 8 gets me this number. Not that number. I think I must be copying too quickly. My computer can't keep up to me. Slow latency. All right. So now I'm at bytes, right? And I want to ultimately get it into megabytes. So if I have this many bytes, what do I need to do to get it into kilobytes? Divide it by 1024. We will have fewer kilobytes than we have bytes. So we divide. That make sense? All right. And then what do I need to do to get it into megabytes?
Divided by another
Divided by another 1,024. All right, and that will get me into megabytes. So the first divide gets me kilobytes, the second divide gets me megabytes. So your final answer here should be 0.0025 blah blah megabytes.
Huh.
Make sense?
Yeah.
Okay. And this would have come in handy. They don't do it too much anymore, I think, because the speeds have gone up some. So, even your dumb consumers are smarter than they used to be. Because if you went into a Best Buy 15 years ago, something like that, maybe even a little longer than that. It probably was longer than that. 15 years ago wasn't all that long ago. I mean, for you, time starts really going fast when you get older. But the point is that you would go in and if you were shopping for a computer, it would list the size of the computer's hardware like in bits. That way, you got to show this gigantic number. So, like, as the average shopper, you're looking like, man, this thing has 14 quintillion bits. Never gonna use that. Yeah. And they totally did that. It's so funny. Yeah. I mean, the things wouldn't even fit on the thing they were printing. It's like, yeah, we just gave up printing it. This hard drive's so big, you'll never fill that. So, but then now we know how to do the math. We can figure out like, oh, that's a 128 gigabyte hard drive. It's like, I mean, it's fine for most things, but I mean, if you're going to store your Bible documentaries on there, it's not going to. Now, the funny thing is, here at Concordia Christian University, why are we getting Snickers from storing your Bible documentaries? We probably need more Bible homework in here, don't we? That's what it seems like. All right, let's see. How could there be so much air in there? That's ridiculous. We have to go over to the physics department and take their fluid dynamics class. Oh. We're at the end now. Oh! Now it's a nice frosty Coke Zero. It's perfect. It's like the perfect kind. It's like the crushed ice, not the normal ice cube. Oh, those are the best, right? Oh, delicious. Natural Coke Zero Spring came from the Avian company. Go ahead.
We're getting higher upload, but it's 31 megabits.
Yeah, first of all, Concordia has a synchronous internet connection, as opposed to at home. When you mention your download is higher than your upload, that's what would be called an asynchronous connection. Not important for us in here. Take a networking class. Well, all the classes that deal with numbers like this, I teach. But the punchline is I'm not going to ask you about synchronous versus asynchronous in here. But synchronous means same speed up and down. Asynchronous means different speed up and down. Concordia has commercial business internet that we buy from like multiple sources, so we have a backup. So it's just a hard problem that universities and big enterprises try to solve. So sometimes, and we also have servers on campus that do like QoS stuff for quality of service. And what you might have during the day is they might reserve download bandwidth on some of the networks. So maybe like the faculty network and the network that the labs are on might have more of the download bandwidth dedicated to it, which then frees up that upload because, as we mentioned, we're not using the upload as often, right? Now, I noticed it where it benefits me is at the end of class when I upload my video. If you hang out for a second, my video from class is like a 2 gigabyte video. It's uploaded in like 9-10 seconds. A majority of the time. So yeah, I mean that's a benefit. Go ahead.
So like at some points, you said you had a backup for like.
Concordia?
Yeah.
Yeah,
So then why does when the power, I've noticed this sometimes where like you send out an email where it's like all the computer system like shut down or whatever and you can't access the internet.
Well, I mean, that's going to be because there's no electricity to campus. So the servers, our routers, they're called edge routers, where the internet's coming in, they lose their power. We can put them on a battery backup, but usually we'll take that opportunity to actually do any sort of patches and shut them down, and then reboot them, because none of the other machines on campus are running. So you might have that one campus computer where you have your battery backup on it and you can stay alive for 45 minutes or something like that, but if you really care, give yourself a Wi-Fi hotspot from your cell phone and move on with life. But yeah, I mean, if you don't have electricity, it doesn't matter if you have 30 backups for your internet pipe, without just tons of Tesla batteries laying around, we're going to be in trouble. Yeah.
Maybe a term here, internet is like gigahertz. What is that?
Internet would be never measured in gigahertz. Are you talking about for Wi-Fi?
Yeah.
Okay, so when you have Wi-Fi, when you see something like 2.4 gigahertz, stuff like that, that's like so when you're plugged into the internet in a lab or something like that, you have an Ethernet cable. That's the medium, that's the channel that the internet's traveling across. Okay, well, when you have wireless internet, we don't have a physical cable, so we have to divide up the spectrum of airwaves for what that's going to transfer over. So 2.4 gigahertz is kind of like an interstate. Okay, an interstate in the air, a wireless transfer medium. And then within that, they divided it up into, for 2.4, I think it's 11 channels. 98% certain that's the case. But there's 11 channels that, so you might, if you have two different routers in here, one would pick channel 1, another one might pick channel 7, where they have the less conflict with each other. So it's invisible Ethernet cables. So 2.4 gigahertz would be the name of the interstate, and then the channel would be which lane you're in. Make sense? Yeah, but that's not a speed thing. That's even though it sounds like a speed, it's not a speed thing. It's a delineation of the airwaves that probably they picked for. It actually does relate to speed to some. The higher the spectrum, okay, the higher the gigahertz, let's say, the bigger the theoretical maximum speed you can transfer over there. There's going to be some, point where that no longer helps you because you're going to because of interference in the air and things like that, you're just not going to be able to send it faster. But that does help. So if you're on one of the really, really low ones, you're probably not going to. You don't have enough. It's like a country road. You don't have enough lanes, and even the one lane you have isn't very wide. It's kind of that's the best analogy I can give you. Make some sense? Okay. So let's talk about, at least start talking about what, I know we only have a few minutes left, but let me at least go into this deal. So what I mentioned about bytes and shorts and ints and longs here, we talked about that a byte is 8 bits. We just learned that, right? So when we store things, a byte is 8 bits. When we send things, a byte is 8 bits. All right, so whether we're storing it in a container or we're sending it over the internet, it has a size, okay? A short, that primitive type, is stored as 16 bits. A int is 32 bits. A long is 64 bits. Now, this could be system dependent. It's less of a thing anymore, but way back in the 1970s or something like that, you may have had an operating system that represented integers as 16 bits, for example. But from our perspective today, it doesn't really matter. We're looking at 4 different primitive types that have 4 different sizes. Okay, and these are pretty common sizes for these guys. You should definitely know what a byte is. That's just a computer science baseline. Bytes are 8 bits. You should know what a bit is, zeros and ones. Now, you should definitely know kilobyte, kilobit, those things, those two category things. In fact, it would probably benefit you come Monday to have this thing memorized. Just saying. Yeah. Yeah. So I mean, and keep in mind, you don't really have to memorize it, right? As long as you know these top 2, everything else below that is just multiplied by 1024. You need to know 3 numbers: 1, 8, 1024.
Woo.
Okay, and then just kind of know the names: the kilo, the mega, the giga. Okay.
Is there a difference between the capitalization? Sorry.
100%. That's the big difference. The little one. So I just did everything lowercase over here and everything uppercase over here. But the big thing is look at the B. If the B is uppercase, it's bytes. If the B is lowercase, it's bits. A lot of times if somebody says, oh, this is a 50K file, and they put the K uppercase, they're talking about kilobytes. So uppercase stuff definitely talks about bytes. Lowercase stuff talks about bits.
So watch out for if it going from bits to bytes.
Right. But also keep in mind that in the wild, a lot of times you're going to be going to Best Buy or, Costco and talk to the Spectrum salesman. Actually, Costco is DirecTV, right? But wherever you can go and get to the people trying to sell you Spectrum, 9 out of 10 of those guys are going to tell you it's 200 megabyte internet. Or they'll just say meg and they'll do the flame thing and they'll give you a sticker with fire and all that stuff, right? Get it? So also know who you're talking to, because they might be just feeding you lines. All right? But now all of us should be, we understand enough to not have to worry about that. All right? So I'll look at the next chapter in the book. Probably will give you that one, but definitely huge threat of a quiz on Monday dealing with the conversion between bits and bytes and megabits and megabytes and those things. Okay, you can bank on that one, unless I forget. But as long as I remember, it'll happen. All right? And if you really studied for it, it would behoove you to remind me to get to class. I'll probably remember, but just in case. All right, have a good weekend. I don't think we're getting any more death storms, so drive safe anyways, but whatever. I think it's just cold for a couple of days, but balmy compared to last week. But I'll tell you what, that wind this morning was way worse, because I was going out every day when it was like 55 below, but it wasn't that windy. It was just cold. Yeah, but it didn't seem that ridiculous. Today, I almost died walking in. It was terrible. Yeah, we'll see how fast